Support! Alright, let's get it on. I want to show us something about this. Let's get this started here.
So, let's get started
if
with
you
our,
did something
our
like
actual
this
calculus
in front
stuff.
of me,
Oh, this is going to be awesome. So, with our calculus,
we're going to need to talk about stuff. One, your brick and dryer conjecture numbers out here are tough. You didn't have the real number between the difference of these things. It's mathematics. So you're going to lean into mathematics. There's a reason you would say A is B, but A is bigger than B on the chain of command. They both have similar issues. This one is to inform and empower the crew. This one is to mitigate tasks and ensure that those tasks are done, or at least something to that concept. I do not have the active vocabulary for the language in which that needs to be beep beep. Now, in that idea, I'm ensuring from this side of it, an M2 phase of it, it's like I'm a rank, I'm of rank. If in given the situation that I'm in charge of you and I see something in here, blink, blink. In the Sharp's case on that ideal is this system is the same thing as let's go back to empower and inform a crew, and these things being congruent. Yes. The only thing difference is that there's a standard model for the operations and procedures, and of this system, one of these people will come this up. I'd assume it come up for a reason. Why mission command relative to command lead, maybe? Inside of there is what the difference is. If command lead gives this one to you, then they are congruent by the standards. Back to some of the math inside here. Let's take a line and just make it a 45. Point A and point B. Point A and point B. These are things are what those are. Aren't you supposed to know what's in your area of operations? If from mission command they have idealized which commanding officers have responsibility over to you, mark your feet. How close are you to them and how often you pissing them off? Because that will cause problems in the total overall mission command and the briefs of things that don't need to come up. Beep, beep, correct? Great, great. These are things probably along the pyramid and all this other stuff he's going to be talking about on this board by a different standard. See, these are going to move like electrons. You are going to move down here like a person, but they have congruency at those speeds, and sometimes at different speeds you need different programming limitations for those things. This math problem will put you in the ground. There's a couple of trick answers for it as far as the Jacobian matrix, no matter how you do it, but they're both doing similar systems inside here. Who can handle operations? Who can brick and dryer this? Because they're areas of operations that have different pin chip configurations and standards for that model in a universal loaf. That marshmallow, we're going to draw out the area. The mission command is here. And this is this. Those are really those things. When I put on the HUD, mission command are those names in this system, and that's going to come up floating around in here like an electron doing its task. Now, I don't care what its task is. I should be able to tell from my eyewitness testimony what that was. I seen them there. They did this. This is what they were doing last time when mission command was in this office right here. They were empowering and motivating, informing and motivating the students, yes? Looks a lot similar to calculus to me. So what beyond those things in general relativity do we need to know about the specifics of special relativity, in this case the pain train, which is going to drop F1 plus F2 equals minus F1, and then we're going to change values for the train. Hypothetically, in the scenario, what is the train? Does nobody know? Is it just some little chugga chugga, I think I can, Thomas the Engine chain, or we got something that's a little bit more realistic with real numbers that can be inputted into that value? That value is going to change things. How much work, how much timelines, what are the standard models? Unless they are congruent and you can prove so that those two things are what they are, cost differentials or time to get it. Yes, I'm sure silver kills vampires. Anybody got any silver on them? All right, there you go. Obviously, we're going to have to work on some different model. What else we got? Trap them in a box and blow off the roof with Bernoullis inside of here with a vacuum problem, and in the middle of the day let them all. So some of the standards involved in this are going to just be negative pi over 2. And that's an area, straight line. That's a data compression of this system. The area there, basically 2 pi. In general model, it always goes back to a graph that determines the timeline. This cost, I have rock I can get 12 of them out in 1 hour. So therefore 2 hours. But there's some weird stuff that happens after this first cut, right? After I get all the 12 or 18 done, I got to set up a new pallet system. So it's not just going to be this perfectly clean system. Do they have systems that are graphed on timeline to keep that drop in performance at that straight line moving infinitely in that direction, FMA, forever at the first law? Or is it the second law inside here to those other motions that can be adjusted to keep that on a 45? Some brother down there, you gonna walk over there and say something to him about it? Unless you got law of the land working with you?
Tangent problem, I'll give you a very intro to this.